the 36 first as 6 to some power. I'm just rewriting the 36 part, okay? I know it's 36 to the 4th. I'll get to that in a second. I just want to rewrite the 36. 6 to what exponent is 36? 6 to the 2nd power is 36. Do we all agree with that? So I'm literally going to I'm taking out just the 36. We're going to have to leave that 4 in there, and I'm going to rewrite it as 6 squared. You're all in agreement that 36 is 6 squared, right? Okay. So what I have in my parentheses is the same as the 36 up there, but what's the 36 raised to? The 4th. So I'm going to put this 4 right here because those are now equivalent statements. 36 is 6 squared. It's raised to the 4th. I raised this to the 4th. Now I simplify that exponent. That's 6 to the, what do we do with the 2 and the 4 when it's a power to a power? Multiply. So I asked to rewrite that as 6 to the question mark. All right, let's try another one. Let's try 3 right below it, okay? I'm asking you to rewrite 625 to the 7th. I'm not worrying about the 7th right now. I'm worrying about the 625 as 5 to some power. So I'm going to highlight that. This is where you might need your calculator to help, guys. Would you figure out on your calculator just some guess and check? We know it's not 5 squared. Start putting in exponents to 5 and see what it is to get you a 625. I don't like the glare on that. All right. This is what I'm using, the caret key. So I'm like, okay, 5 to the 3rd. Nope, that's 125. 5 to the 4th. Yep, okay. So let's take out the 625, and we're going to rewrite it as 5 to the 4th. Put it in a parentheses. What was 625 raised to? The 7th. So I'm going to put a 7th there. Simplify your exponents. 5 to the 28th power. Okay, so practicing doing that. Okay, so what if instead of a question mark, I put an X there? So for some reason that makes it scary for people, but we're just doing the same thing. Okay, let's do 2 and 4. So I want to figure out what exponent of 3 is 9 squared. So we're going to circle the base, the 9. Can you rewrite 9 as 3 to an exponent? 3 to the what? 3 squared. And outside, do you see that 9 was squared again? So I'm going to write a squared on the outside. Okay, what's the value of x? It's just 4. This is 3 to the 4th, and I'm asking you to figure out the value of x. Do you feel ready to try number 4 on your own, or you want to do one more together? Okay, try number 4 on your own. This, once again, is probably going to involve you doing some guess and check with the 4. I got that 64 was 4 to the 3rd. Okay, so 4 to the 3rd was 64. right? So this is 4 to the what power then? 24. What's the value of x? 24. Okay. We'll try 5 and then we're gonna kind of come back to this and we'll make it a little bit like, what if I ask you to like solve a little bit further? Okay. Do you remember function notation back from first semester? Kind of, sort of? A little bit? Sorry. So the idea was that we were to take out the x and then we'd put a whole expression in for x. So in this one, I have g, you see there's an x there, and there's 3x squared. So if I asked you to find g of 5x, I mean, let's just take out that x, and we're going to replace it with a 5x instead. So g of 5x, I'm going to just rewrite this, instead of 3x squared would be 3 times 5x squared. So just kind of doing that swap out. Ooh, gosh, order of operations. What comes first, exponents or multiplication? Exponents. So you'd want to be careful. Don't do 3 times 5 first here because that's multiplication. We want to do the exponent first. So we would do 3 times 5 squared times x squared. What is 5 squared? 25. So 3 times 25 would be 75x squared. Okay. Yeah. I'm recording. Okay, so let's now step it up a little bit. If I just, instead of an x, now I have a 2x plus 1, but we're really doing the same thing we were doing on these other 4 problems. So what I want us to do is we're going to circle this 9 over here. And we're going to take that 9, and we're going to write it as an exponent of 3. What is that? 3 to the 3 squared. Okay. So 3 squared, and then do we see we have the 4th? Okay. And we agree that that's 3 to the 8th. I'm not there yet. I'm not doing that part yet. Okay, so in the last ones, I said that, so you see these 3's are the same. In the last one, I had it just an x. But this time, I have a 2x plus 1 is equal to 8. So now we're going to set that whole thing 2x plus 1 equal to 8. Can you solve that for me? X equals 7 halves or 3.5. Okay, that one was a little bit trickier. Let's try another one like that. Okay. Which of the numbers am I going to rewrite? The 125. And a little hint to you guys, if I start messing around with exponent, just focus on the bases and figure out which one you're going to rewrite first, and then a lot of times you're going to figure it out. All right. Do you know what 5 to what exponent is 125? 5 to the 3rd. Okay, so I'm going to just rewrite this side as 5 to the 3rd, and then I have a 4th. Okay. Maybe this will help you. I'm going to just rewrite the 5 to the 6x minus 3 below. I'm not changing it at all. Okay. Do you see how the bases are now both 5s? You see that? These are both 5s. As long as they're both 5s, I can just solve an equation to figure out what the exponents are. What's the exponent of this one? 6x minus 3. Okay. What's the exponent of this one? 12, right? So now I solve an equation. What would I do to do that? Add 3. Divide by 6. What do we get? 2.5? Okay. Let's try another one. Which am I going to rewrite? The 2 or the 4? But can I go any lower than this 2? Yeah. You can't rewrite a 2 if it's already a 2, but the 4, you know what I'm saying? Okay, so because it's on this one, it's like, what? There's x's in both? Oh, we can do this. Circle the 4. We're going to rewrite 4 as an exponent of 2. 2 to the what? So 2 to the second to the 2x minus 8. Agreed on that side? Weird. And over here I have 2 to the 3x plus 2. Do you see I have the bases the same now? Okay. Now we're just going to get the exponents the same. Now be careful. If I took 2 and I multiplied it by the whole thing, 2x minus 8, wouldn't you make sure you multiply both things? What would you get? 4x. Good. I get 4x minus 16 is this exponent. And it has to equal, over there, what? 3x plus 2. Would you do that for me a minute? Would you finish it? Okay. I think I got 18. So I subtract 3x from both sides. I get x minus 16 equals 2. X equals 18. Okay. Let me see if I can find any others like that. I think that was it. We'll do a little practice in a second. Okay, let's do some of these. Simplify. I don't know. How do I simplify that? I know. I'm asking you. Is there what are the ones that have the same bases? The sevens. Okay. Now, normally if they were numbers, you could do this. I know you could because you showed me you could. Normally, what rule would you do with this? You just add them. So I'm going to do the same thing. It's just that they have an x in them. This is the same as 7 to the, what's 3x plus 5x? 8x plus 2 to the x. Is there anything else I can do with that? Oh, no. The exponent rule says, let me write it somewhere else. If I had like 2 to the 3rd times 2 to the 5th, that would just be 2 to the 8th. Okay, you're using that same base. You can rewrite it as a single base. Okay? Okay, let's try this one. 11. Put those together. It's b, is it b to the 10th, right? Plus b to the 4th. What is it? Is there, Miss, are you expecting that we do chunking on that or not?
No, I think we're expecting them, what I think I was getting at there.
You can't put those together.
You can't put those together. Yep. They're not like terms. They don't have the same exponent. You can't add them.
Okay, let's look at number 12. Very similar. Are the bases the same? Yes, you can write it as one expression. We should add the exponents. Okay, well, what's 2x minus 5 plus 1? Can you add anything together in those exponents? You can add the negative 5 plus 1. I could rewrite this as 3 to the 2x minus 4. Okay. Let's go back and look at question 10. It says x to the third, a to the, x to the third, a to the third, there's a lot of variables in there, is x to the b 64. What's a plus b? What's our job here? What do we have to find? We have to figure out a and b. All right, so I'm going to say, well, I know that x to the third, x over a to the third is the same as x to the third over a to the third. Agreed? Okay. So I'm going to point something out to you. One of them's right there for you. What's b equal to? 3. Okay, so we know b is 3. How could I figure out a? Yeah, there's some number cubed that gives you 64. Can you find it? What if you didn't know? Then start plugging in numbers and checking, okay? But like for instance, well, is 2 cubed 64? No. No, see, I'm just doing my calculator. Is 3 cubed 64? No. Is 4 cubed 64? Oh, cool. What's a then? A is just 4. 4 plus 3 is 7. Anything you want to add on that?